Hi there, and welcome back to part 8 of our little tutorial series about creating the classic game Pong in Unity in 2D. Today we'll be talking a little bit about 2D graphics, so-called sprites, and also a bit about the separation between the gameplay logic, aka the physics in our case, and the presentation of the game, aka the visuals. So I changed the plan for this series a little bit and put this part in before the very end, because 2D graphics, it's just a big part of developing a game in 2D, and also because you can do cool things with it. Check this out. I remembered this post from Kate back in May, and she was following the tutorial series and created a bee-themed version of the game. How awesome is that? So we'll learn to do something similar today. This little change of plans is actually a bit of a metaphor for game development in general, as while developing your game, new things and ideas will pop up all the time, and you really gotta prioritize which things will matter in the end and which are important and which are less important. There's this thing called scope creep, that your game always gets bigger in your mind while developing it, but you only have so much time to finish it. So what I want you to take away from this is prioritize and concentrate on the important stuff. If you are new to this series, I highly recommend starting at part 1. I got this handy playlist on my channel, so you can just watch them all through, because they are building on top of each other. The link to the playlist is also in the description. But if you want to dive in right now and just follow along, we got a GitHub repository, and after each tutorial I created a tag so you can check out exactly the state of the project after each video. So far, our Pong game looks rather abstract, just like the original. So we're just using squares for all the visuals, like for the walls and for the ball. You see these on the sprite renderer component, and also for the pedals. And you can totally create a game in this abstract style. A lot of cool and successful indie games have been created like this. Just a few examples, like Thomas Was Alone. These are just colored squares, and they got so much personality, and this is just such a great game. Or take, for example, Limelight. It's just very simple graphics, and both of these games manage to be amazing and also emotionally touching in their abstract style. But we want to learn as much as we can, so let's check out using some more sophisticated sprites and the problems that could come along with using them. And since we already have some stars in our background, it is only logical that we go for space as the visual theme for our game. You could now go on and create your own graphics for the game using awesome freely available software like GIMP or Krita, for example. But this is beyond the scope of this tutorial series, and there are many tutorials on this out there. So just do a quick YouTube search and you will find a lot. Instead, we will use art that has already been made by others and made available to use in your game. So what I recommend is going to opengameart.org and then browse to 2D art, and we can search for, let's gather a background for our game. And for this series, I'm gonna go with public domain assets only, so that we're totally on the safe side. So there are multiple licenses here available, and for most of them you gotta credit the author. For public domain you don't have to do this. It's still a nice thing to do, and we're still gonna do it, but yeah, let's just check out public domain assets now. So I think this one here, space backdrop, could be a good one. Yeah, it's subtle enough, and yeah, we can just download it by clicking here, and then we have it downloaded. And once again, check probably this description. Sometimes the license is a different one given in the description than it is here on the side, so be careful with that. Another website for assets that I highly recommend is Kenny.nl. Kenny is creating lots of cool game art, and it's all available in the public domain. So we can just go to Assets, 2D, search for space, and then we get a lot of cool stuff. And let's check out this space shooter extension kit, and it's got like some rockets in it that we could use for the pedals and some spaceship that we could use for the balls. So let's download this one too. Let's put our new assets into the game, and for this just navigate to the folder where you downloaded them and drag and drop them into your sprites folder. I already unzipped this Kenny Space Shooter extension folder here, and here we gotta navigate a little bit more. I'm gonna go to the higher resolution of the sprites, and I'm gonna pick this rocket and drag it in. Feel free to choose another one and see how it fits. And then we also got ships here, and I think I'm gonna go with this one. It looks cute. And one more thing, in the first part we created this this project as a 2D project. If you didn't do this, then maybe when you drag in these sprites, you can see this on this little arrow right here. If they don't have this arrow, you gotta change the texture type. It's gonna be on default, maybe, and then you have to change it to Sprite, to the UI, and click this little apply button here. It shouldn't happen, but if it happens for you, or maybe in the future, you know now. Let's add our background to the game, and for this create a new empty and call it background, or maybe background holder. So since we have the stars now in the background and also our space field, let's create an empty parent for this so that we can group them together. So now let's create another empty, and let's call this one space field. Add a new component of type sprite renderer to it, and now for the sprite just drag in this space field graphic. You can also choose this little icon right here and choose it from this dialog that pops up. And now let's check out our space field, and it's a little too small, so let's make it bigger. Maybe 1.5 will cover it. Yes. But oh no, what just happened? Our walls and our pedals disappeared. This is because the space field is currently drawn in front of these, or maybe on the same layer as these, and then it's random which one gets drawn in front. And to change this, we can change this sorting layer. So we have order in layer, we can put this probably to -1, and then everything else gets drawn again because it's on 0. But let's create a new sorting order for this, a new sorting layer, excuse me, and let's call this one background. So these are like two hierarchies for sorting sprites back to front. And the background, of course, it's gotta be behind the default layer. So we will just drag this up here. And now we can give our space field the sorting layer background, and everything is good again. Now we got another background element, and this is the stars. So let's also put them on the background layer. Notice this is a particle system and not a sprite renderer, but we can also change its layer order, and this goes for other components like the line renderer also, as we'll see later. So go to the particle system, to the stars, and scroll all the way down to the renderer module, click on it to expand it, and then all the way down, we got this sorting layer ID. This is currently set to default, so let's set it to background, and now our stars in our space field are on the exact same layer, so it's random which one gets drawn in front. So it could happen that our stars become invisible. And for this we can use order in layer and put our stars further to the front. So let's give it an order in layer of 10. Notice that we could have also given these stars an order in layer of 1 and it would still have worked, but I just wanted to show you something else, and that is increments of integers like these. It's good practice to do it in higher increments than 1, because you can't go between 0 and 1 on integers because they are whole numbers, but you can go between 0 and 10. So if we want another background element that is drawn between the stars and the space field, we could just set it to order in layer 5. Whereas if we went here with an order in layer of 1 for the stars, we would have to adjust the stars up and then put something in between. So yeah, I just wanted to tell you about this practice. And yeah, for now, this is our background all done. Let's continue with the pedals, and for this, open the pedals in prefab mode, and just assign this space rocket to the sprite renderer. And whoa, these are huge now. That is because we scaled the pedal up. What we need to do here is separate the logic, the physics logic, aka our collider size, this little green box here. I hope you can see this in the video. Yeah, separate this one from the presentation, from the sprite, so that we can change them independently of one another. The easiest and most straightforward way to do this is to put this transform on just 1 and 1. So now the sprite has the correct size, but the collider has changed. And in the box collider component, we can change its size to what we had before. So 1/3 and 2, and now we got the same size again. And a not stretched sprite, but it's still too big. So now we got the same collider size as before, but the sprite is still way too big. And now we could go the route and adjust the collider size to the sprite size, but that would make this a totally different game, because then the pedals would be super high and it would be very hard to score a point. You can go this route and you can go somewhere in between what we want to do, and what is mostly done in general in game development is adjusting the aesthetics to the gameplay. So in this case, adjusting the sprite size to our collider size. So mostly when developing games, you want to get your gameplay playing well in the first place, and after that make it pretty without changing the gameplay. There are exceptions to this, of course, but this is just a rule of thumb. So let's do the separation. Let's create a new empty and let's call this one pedal sprite. And now we want to get this sprite to the other game object. And for this we can click this component, these little dots here, and choose copy component. Now we got it in our clipboard, so to say, and we can remove it on this parent and we can paste it in here by clicking these dots again, then paste and component as new. But be careful when doing operations such as these. If we had like a reference to this component on the pedal, then this one would get lost and we would have to assign this new object again. Now we can adjust the sprite size independent of the collider size. So let's try 1/4 and let's zoom in on this one. And now we don't have the collider on this one, so we have to select the pedal to see the collider actually, and we can see it fits perfectly on the x-axis except for these wings, but we're not gonna have them inside our collider. You can try this out with a polygon collider and see how this works, but it will probably get a bit crazy, but maybe in a good way. But it's also probably gonna mess up the angle calculations that we did in the last tutorial, but I encourage you to try it out. So the height is almost good, almost perfect, but I think we're gonna leave it at that. Sometimes you want to leave colliders a little bit smaller or bigger than the actual visuals to give the player a better feeling, a more powerful feeling. In this case, it is bigger so that we can hit balls that are just up here. So the player feels like, oh, I got this one just before it slipped away, so they feel good. And maybe you want to do like a different size on the right pedal. Okay, we also got a 2-player mode, but if we are playing against the AI, you might want to decrease this height here a little bit, this Y size of the collider, so that the AI player has it a little bit harder than the player, for the player to feel even better. But that's all up to you how you decide to design your game. So now we got our pedals pretty much done, but I have a little bonus task for you. So try giving these pedals, these rockets, a little particle effect for the thrusters, and bonus points to you if it changes with the speed of the pedal. Are we done with the pedals now? Not completely. Remember the last part when we angled the ball, and let's go into our pedal script, and we angled the ball depending on the height of the pedals. And this is not correct anymore. So we changed the transform local scale to 1 from 2. The actual height of our pedal is now determined by the size of our box collider. So let's add a reference to the box collider and call it call2d. And now we can get the height from this box collider. So let's put in call2d here, size. This is the size of the box collider, like we see in the editor, and the height, the Y size. So back inside the editor, just gonna let it compile real quick and open the pedal prefab, and now we can assign the box collider here, and now the getHeight method gets the correct height from this box collider component. Let's move on to giving our ball a sprite now, and we're going to do pretty much the exact same thing at first. Let's create an empty child and call this one ball sprite, add a sprite renderer component to it, and drag in this spaceship and remove the sprite renderer from the parent game object. Now a cool thing we can do with the sprite renderer is flip it. So you see this flip right here, and we can flip this spaceship on the x-axis, which is gonna do nothing because it is mirrored on the x-axis. And if we do this on the y-axis, we see that it's flipping. But what we want to do is make it face left or right, depending on the movement direction. And for this, we got to give it a rotation of 90 degrees. So now it is facing right. But now this is a little counterintuitive, but now we want to flip it actually on the x-axis, but since it is rotated, this one is not going to do anything. It's going to do the same thing as before. We just flip it on the x-axis. But since it's rotated, we gotta use the y-axis now. And now we gotta adjust this ball collider to fit the ball sprite or the other way around. So there's multiple ways we could go about this. We could change this scale again to 1, 1. But yeah, this would make it much bigger, and then we would have to adjust more scales like the collider and the sprite on different objects, and maybe also the collision particle and the trail. The easiest thing to do here is just scale this sprite down a bit. So let's go for 7.5 and let's see if this fits the collider, and it fits well enough for now. So we might do a little cleanup on this later, because in general I would recommend leaving parent objects on a scale of 1, 1, so just unscaled, and just scale the child objects. But since we have so many child objects here, we would have to scale them all. So the easier way is to just scale this sprite. But this is a decision to be made on a case-by-case basis. Next up, we want to flip the spaceship, aka our ball, in the direction it is moving. And for this, we're going to go into the ball script and add a reference to the sprite renderer, and just quickly wait for it to compile and assign this one. This time it's not on the same game object, but on the child, and assign this one. Now back inside the ball script, let's scroll all the way down and add a new method to adjust the sprite rotation. I'm not calling this flip sprite or check flip sprite, because right now it is checking to flip the sprite just left or right. But maybe we want to do something else with it in the future. So let's call it rotation. So it can rotate maybe at different angles and not just left and right. And what we're doing in here is checking if the horizontal velocity of the rigid body is below 0. If it is, then we say it is flipped. And if it is not, if it's going to the right, then it is not flipped. Like we saw in the editor, like the default flip is to the right. And then we just set on the sprite renderer this flip y variable to is flipped. We could actually make this even smaller and just put this in here and make the bool go away. So this gives us a Boolean back. And now all we got to do is call this adjust sprite rotation method. And where do we do this? I think we're going to do it in the on collision enter 2D method. And maybe we're gonna do it for walls and pedals, because maybe we want to change the sprite rotation also if we hit a wall. Now back inside the editor, let's see if this actually works. And let's start the game for this, and yeah, just go with it. And it is rotating to the right and to the left just as we want it to. Not actually rotating, but flipping. Okay, so this is working as expected, but we still gotta do some more things. Right now, our ball, our pedals, and also our trail are all on the same layer, and it's not that visible right now, but it could cause us visual problems in the future. So let's adjust this and make this more clean. So let's put the pedals maybe, yeah, this one we're gonna leave at 0, so they are the furthest behind. So for example, our spaceship is in front of these wings of the rocket, so I think that makes visual sense. So then the trail of the spaceship, maybe you can't see this, it's all the way down there. I think my camera is probably disguising this. So we can set this one to 10 all the way at the bottom, and the ball sprite actually is gonna be rendered above the trail. So this one we're gonna give an order of 20. So now we got the ball pretty much all done, but I want to give you a little bonus task. So this adjust sprite rotation method, try using it with the angle we calculated in adjust angle, so that it's not just flipping left and right, but at really the exact angle it is going. Yeah, I encourage you to try this one out, see how it feels, see if it feels better or worse than just flipping the sprite, and generally learning from doing it yourself. Two more things I want to cover, and the first one is the post-processing. So we added quite a bit of post-processing in a previous video, and now with our sprites the rockets are looking a bit weird. This is a style that you could totally go for, but you can also try adjusting the post-processing now. So probably switch off chromatic aberration so that these rockets look like the graphics they are using, or maybe turn off the color grading so that we can probably see the background a little bit more. It's a bit of a subtle background, but yeah, try playing around with this and try giving your game a unique visual identity. The other thing I want to do here is give credit to the creators of the visuals we used. So we used this space backdrop by Baron77 and also Kenny assets. And we can do this on our itch.io page. Yeah, so let's just add this one right here, graphics by Kenny and Baron77. And we can also do this in-game. So let's go into our canvas, into the menu, and maybe we will just duplicate one of these tutorial texts for this, move it out of the tutorial text and call this credits text, and enter this text right here, and then we will probably anchor it at the bottom. So do it like this, maybe give it a bit of a higher width so it's all in one line, and also not have it right, have it on the left and in the middle, and maybe give it a black color so it stands out a little bit more. So that's it for this part. So we got the sprites all done and can tick them off the list. So, and I encourage you to try using all different graphical assets, different post-processing. Just give it your own spin, just like we saw in the beginning with the bee theme by Kate. And yeah, let me know in the comments or on social media. Just link me or post the name of your itch.io page in the comments so I can check out your creations. If nothing else comes up, we got two more parts actually, probably. I think I'm gonna divide this in two parts coming up in this series, and one is for cleanup and the other is to give an outlook. In the meantime, let me know your feedback, questions, comments down in, well, the comments, and I hope you enjoyed this series so far and will tune in next time again. Have a great rest of the day, see you here again soon, and bye!